Production technology preparation. Mold designers carry out product analysis to gain a detailed understanding of the product's structure, dimensions, accuracy requirements, appearance requirements, etc., and assess whether the existing mold structure is capable of achieving mass production. Mold design. According to the results of product analysis, design 3D engineering drawings, loose parts drawings, mold dividing drawings, assembly drawings, EDM drawings, etc. to determine the structure of the mold, size, accuracy requirements, etc. Formulation of process technology documents, including process routes, processing methods, processing allowances, heat treatment requirements, etc., as well as the formulation of material quotas and processing labor hour quotas. For material preparation, according to the requirements of the product and the environment in which the mold will be used, we choose suitable mold materials such as P20 steel and H13 steel. Meanwhile, in order to shorten the manufacturing cycle, existing standard parts are utilized as much as possible. After the mold material arrives, the mold engineer checks whether the material is qualified and meets the requirements for manufacturing and processing. Rough machining is then carried out, using cutting equipment to cut the raw material into approximate shapes and sizes, leaving 0.5 to 1 millimeter of machining allowance for subsequent finishing, including removing most of the allowance and machining out the basic contour. Rough machining can improve machining efficiency and reduce the workload and cost of finishing. Then heat treatment, quenching, tempering, and other heat treatment of some key parts to improve the hardness, strength, and wear resistance and other properties of the parts. The heat-treated parts need to be tested and analyzed for hardness and other tests to make sure that there are no problems such as offsets and scars. Using CNC machining centers, EDM, and other precision machining methods, the parts are processed with high precision to ensure the dimensional accuracy and surface quality of the parts. This includes fine machining of key parts such as cavities and cores to meet the molding requirements of the product. After fine machining, the surface of the parts is treated with polishing, nitriding, hard chrome plating, etc. in order to improve the surface hardness, abrasion resistance, corrosion resistance, and demolding performance of the parts, so as to improve the service life of the mold and product quality. Assembly debugging. The first step of parts cleaning. Cleaning of processed parts. Remove oil, iron filings, and other impurities on the surface of the parts to ensure the cleanliness of the parts. Then the mold assembly. According to the requirements of the design drawings, the various parts are assembled, including the installation of cavities and cores, the installation of the ejection mechanism, the installation of the cooling system, and so on. In the assembly process, it is necessary to pay attention to the matching gap and installation order of the parts to ensure that the overall structure and function of the mold meet the requirements. After debugging inspection, debugging the assembled mold, checking whether the opening and closing action of the mold is smooth, whether the ejector mechanism is working properly, whether the cooling system is leaking, and so on. At the same time, it is also necessary to check the dimensional accuracy and surface quality of the mold to ensure that the mold can produce qualified products. Trial mold and identification. The mold will be installed in the injection molding machine for the trial mold. Through the trial mold, can test the mold design and manufacturing quality to find the problems of the mold and timely adjustment and improvement. It is necessary to select suitable injection process parameters, such as injection pressure, injection speed, holding time, cooling time, etc., during the mold trial to ensure the molding quality of the product. The quality inspection of the products after the mold trial is conducted, including the inspection of appearance quality, dimensional accuracy, physical properties, and so on. According to the inspection results, the mold is evaluated and appraised to determine whether the mold is qualified. If there are problems with the mold, adjustments and improvements need to be made until the mold can produce qualified products.